An invisible force with massive impact. That's the power of magnets. From tiny toys to high-speed maglev trains, the attraction and repulsion between North and South poles drive our modern world. Mercury is the only metal that remains liquid at room temperature, known as quicksilver. It's incredibly dense and essential for precision instruments like thermometers. Fascinating, yet highly toxic. The physics behind this firework is Newton's third law of motion. As the gunpowder explodes, it forces gas downward, creating an equal and opposite reaction that thrusts the rocket upward. Once it reaches the top, the explosion follows the law of conservation of momentum, spreading the sparks symmetrically in every direction. Why, y'all? Hot CO2 is lighter than air, so it rises and fills the beaker from the top down. This smothers the tallest candle first. It's a perfect look at convection and gas density in action. 350 kilometers per hour? No problem. This is inertia. Since the coin and the train move at the same constant speed, it stays perfectly still. That's pure physics. Train wheels are conical, not flat. This shape uses differential geometry to automatically center the wheels on curves, preventing derailment. Directional blades create airflow. Open spokes don't. That's aerodynamics. Newton's first law says objects are lazy. An object at rest stays put, and an object in motion keeps rolling, unless a force, like your hand, stops it. That's inertia in action. Essentially, what you're seeing is a beautiful interaction between magnetism and fluid dynamics. This is mainly based on two things. Number one, magnetic field, geometry. The small rings arranged in a circle are powerful magnets. Each magnet creates its own magnetic field, and when placed in a ring, they create a combined symmetrical magnetic field across the surface of the plate. Number two, Faraday waves and surface tension. When the liquid drops hit the surface, they create ripples. In physics, these are often related to Faraday waves because the liquid is sitting within a specific magnetic environment, and sometimes the liquid itself is ferrofluid or influenced by the magnets. The ripples don't just spread out randomly. Ever wondered how this huge circle fits through such a tiny hole? It's not magic, it's geometry. When we fold the paper, we aren't changing the size of the hole, but we are changing its shape. By folding it diagonally, the hole stretches into a wider opening. This increases the effective width without changing the total perimeter, allowing the larger disc to slide right through. It's all about manipulating space and dimensions.